Hello, today I'll be starting a new series where I'll try to walk through all of the Leetcode problems of the Neetcode 150 roadmap. I'll be trying going into certain amount of orders, but my goal here is to walk through the problems, show the solution and how I would get there, and also proving them to make it more intuitive and easy to remember. So this is the contains duplicate problem, in which we are given an integer array nums and we need to return true if any value appears at least twice in the array, and return false if every element is distinct. In this case, in our first example, we can see that we have two ones, so we would output true. We have no duplicates in example 2, we output false. In this case, we have many types of duplicates, doesn't matter how many, either way we return true. So let's kind of look through some of the simpler ways we could get through this problem and basically progress to try and squeeze out as many optimizations as possible. So the first thing we would do is we would focus on number 1. So let's go through the entire array, okay? And what we would want to see is there any other element that contains 1 other than the one we're checking? In this case, we see after going to 2 and 3, we finally get to 1, and therefore we should output true. Now let's go through it, and that was a rather fast solution. In this case, it only took O of n time because we only had to traverse through the array once. But in this, there are many worse scenarios that can happen. For example, let's say instead of this being a 1 in the beginning, let's give it 4, and then let's put it at the very end, we have another 1. So we would first focus on the element 4, we go through the entire array, see no other 4, we would then do the same exact thing for number 2, go through the entire array, except for this one, and we would see there's no 2's until we finally get to 1 where we see that we have a duplicate. But by that time, we already searched the array multiple times. Basically, we've searched it the same amount of times as there are elements, which would make this an O of n squared algorithm. And the reason why this is so slow is whenever we're searching for an element, we have to go through the entire array, which is an O of n, which takes O of n time, but we can actually do this in constant time by using a different data structure. If you're familiar with hash maps, then these should be pretty intuitive. If not, I'll explain it. Either way, this is a hash set, and basically you can have a bunch of different elements in there with no duplicates. And what basically is different about a set than an array is if I want to search for an element, if I want to search for a certain number, in this case 2, I can just find that O of 1 time. And this can be very useful for a problem, because let's just say the first thing we do is we go through the entire array, and then we create a set of all the different elements. And this makes it so whenever you want to search for a duplicate, it will take O of 1 time. But there actually is a small error in this. And watch what would happen. I would first go through the array. I would add 4, 2, 3, and then 1. The second time through to check for duplicates, I would go on 4 and immediately see we have another 4. But what the program doesn't understand is we've actually already seen there's only one 4, but this 1 4 is the one we put it into the set. So it actually isn't a duplicate even though we can find it. But when we do have a true duplicate such as this 1, it'll still be found in the set, but we won't know if it is a duplicate. And the actual better solution will be a lot more intuitive, will be a little bit more complicated, but will be a lot faster too, because this time we only need to go through the array 1 time. So what we're going to do is we're going to start with 4 and an empty set of all the numbers we've seen so far. So the first thing we would do is check, is this 4 in the set? In this case, it's not. Either way, I need to add it. And we'll keep on doing this process by checking is 2 in the set, is 3 in the set, and either way we add it. And finally we get to the end, and when we see that 1 was already in the set, therefore we know there was a duplicate. If this was a number, different number, we would just say it was a 7. We would eventually add the 7, and by default we could just return false if we didn't return true earlier. And in total this would be a O of n solution. You might be thinking, hey, we first checked this 4. What if there was a 4 at the very end? Wouldn't that mean we're having some type of error because this set is missing all these other elements? But we can actually continue the process from left to right, because when we don't return a duplicate for the first 4, we add it in. When we finally get to the last 4, we would actually see that 4, and then we would end up returning true anyways. Now I'm going to show a simple way to code this in Python, just so you guys can see an example and see this in another language other than English. The first thing we need to do is initialize our set of numbers. We'll just call it found numbers, and we can just call it a set. And now what we're going to do is traverse through the entire nums list. And the first thing we need to check is if num is in our found numbers, we return true because that means we saw the same number earlier. Either way, what we're going to do is say found numbers dot add into our num. At the end of this, if we never return true, that means there was no duplicates found, and we can return false. And now let's submit this. And it looks like we got a pretty fast solution, which is better than 72% of them. Now, I don't recommend you really pay too much attention to the percentiles. It's more important to analyze complexity. In this case, we have O of n. Now, unfortunately, Leetcode doesn't allow you to always analyze complexity. But still, this is a really fast solution, and it's a lot better than our original O of n squared. Anyways, if you enjoyed this video and found it useful, please give me a thumbs up. Hopefully subscribe for more explanations. Like always, bye-bye.